Hello everyone. Thank you for tuning in. We have already done 3 lectures. So two lectures. This is the third lecture. And this is we are starting a new topic. Before going on into the questions of new topic, we will first of all have some introductory sessions, a very brief explanation of the variables that we will be dealing with, and then we will try to manipulate, and then we will do the problems. So okay, so the next chapter is kinematics. As you all know, the kinematics is the heart of physics. Of course, we don't deal with force, so force is force will not be discussed. However, we have several variables to deal with: initial velocity, vi, final velocity, vf, average velocity, vav, acceleration, time, and distance. Now, to physically describe what initial velocity is, what final velocity is, what's average velocity, and what's acceleration, we have designed a problem, and that problem will help us to figure it out, that what do we mean by initial velocity, what do we mean by final velocity, and so on. So there are two policemen, they are trying to calculate, they're trying to measure the speed of the incoming vehicle, okay, and they are separated by a distance d, okay, separated by a distance d. The first person measures the speed of the car. That speed is the initial speed of the event that we will be dealing with. The event is the car starts, might be possible it has started somewhere else, it crosses this person and crosses the other person. That's the event. And the velocity that you initially measure is called the initial velocity, of course, and the time of the starting of the event is usually taken as 0. So at this point, this person measures the velocity vi, and the time of measurement of this velocity is 0. It crosses this person, and there is another person at a distance d from the first person. He measures the time, so he measures the speed, and that speed is the final speed or final velocity. And the time that this person has taken, the time at which the person has taken the measurement is the total time of the event, or t, okay. These are the simple concepts of initial and final velocity. So there can be 3 scenarios. The first scenario is initial velocity is equal to the final velocity. There are some suppositions in this experiment. In this experiment, we assume that everything is behaving uniformly or in a predictable manner. The car does not stop in the middle, and then the driver goes to drink some tea and then comes back and sit. It's not like that. We assume that the car driver is doing in a very predictable manner, in a very mathematical, or in a very in a way that we can easily mold into mathematical equations, okay. There can be a case where final velocity is greater than the initial velocity, and that's the case of acceleration. There can be a case where initial velocity is greater than the final velocity. That's the case of retardation, Okay, now these two cases where initial velocity is not equal to final velocity, they are very interesting. And these two cases, we we will we will categorize this whole category into the acceleration category. And now there is a new quantity, acceleration, that has appeared, and it has to do with the change in velocity, of course. That means wherever there is a change in velocity, there is acceleration. Very strange. But what this acceleration quantity itself is, okay? To go with the acceleration, we take the change in velocity divided by time taken, okay? So we have the initial velocity as, consider in this example, the same example here, the first policeman, he measures the initial velocity 2 meter per second, and the final person, he measures the final velocity as 10 meter per second, and the time that this person has encountered is 2 seconds. Here it was 0 second, and here is 2 seconds. So acceleration is mathematically defined as the change in final velocity, the difference between final velocity and the initial velocity, to the how much time that has been taken. Okay. All right. So our final velocity was 10, and initial velocity was 2, and the time taken was 2 seconds. The answer appeared to be 4 meter per second square. Now let's describe what this 4 meter per second square physically means. Okay, what it gives you, what physical meaning it gives you. Since the total time of the travel was 2 seconds, we will divide this travel into 1 second. Okay, and this 4 meter per second square means that after each second there is an increase in 4 meter per second in the velocity of the vehicle. Okay, that means after 1 second the car will be somewhere in between. Okay, and its velocity will be 2 plus 4, which is 6. Okay, and after another 1 second the velocity of the car will be 6 plus 4, which is 10. Okay, so acceleration is the quantity which tells you about the change in velocity per unit time. Okay, so for each second there was a positive increase in 4 meter per second, so that at the end of 2 seconds you have a velocity of 10 meter per second, right? Let's take another example to help you more. The initial velocity was calculated to be 3 meter per second, and the final velocity was calculated to be 12 meter per second, and the time taken was 3 seconds. So we divide our interval into 3 parts: 1 second, 1 second, and 1 second. Okay, and okay, so our acceleration is 12 minus 3 divided by 3, which is 3 meter per second square. Now what does this 3 tells you? It's a positive 3. This positive 3 means that after each second the velocity will be increased by 3. So 3 plus 3, 6, 6 plus 3, 9, 9 plus 3, 12. Okay, so at the end you have a velocity of 12 meter per second for a whole interval of 3 seconds. So this is the concept of acceleration. It's the physical concept of acceleration. What do you mean by acceleration? All right. Again, now this is the last concept, I think, which is the concept of average velocity. Taking the same setup, we have two policemen measuring the initial and final velocities, 2 meter per second and 10 meter per second. Here our velocity is 2 and here the velocity is 10, and the distance between the two the d is actually 100. The two policemen is 100. Now the concept of average velocity, it's such that it says, what the concept says, it says rather than having a different velocity at each point, why can't we have a same velocity with a constant velocity such that the distance covered remains same as well as the time taken is also same. That means that you can achieve the same distance in a given time with a constant velocity rather than with a varying velocity, and that constant velocity is the average velocity. So the formula for average velocity is vi plus vf divided by 2. And how this formula came? This formula came by making sure that the distance traveled in both cases is the same. Okay, so the total distance here and the total distance here does not change. Thank you.